Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dr. Jr., your math tutor, and I'm also an instructor of mathematics at the University of Liberia. In today's lesson, we want to look at higher order derivatives. Now, higher order derivative is a form of finding the derivative of another derivative. So we can find the second derivative, we can find the third derivative, we can find the fourth derivative, we can find the nth derivative of any expression. So we want to look at the first few set of problems. That is, we want to find the second derivative of these problems. In the second video, we will find the third derivative. In another set of videos, we will find the nth derivative of different types of expressions. So to find higher order derivatives, it's just like I said initially, differentiating another derivative. For example, if you have y equals to 2x plus 1, for instance, you find y prime, right? Which is equals to 2. Then you want to find the second derivative. So you increase the stroke, say 1, 2, second derivative. So it's equals to 0. You want to find the third derivative, you increase the stroke, 1, 2, 3, it's equals to 0. You want to find the fourth derivative. Now, for fourth derivative, you notice that we're no longer using the strokes, but rather we put the 4 in parentheses. So this implies that whenever you want to find from fourth derivative to nth derivative, always put it in parentheses. So the nth derivative of this expression, will just be equals to 0. At n is when n is equal to 2. So when n is equal to 2, immediately you know that it is 0. So this is the nth derivative. Now, what if you want to attach the derivative notation before finding that derivative? Assume we want to find the fourth derivative, and then we're about to find the fourth derivative, but we want to put a notation to indicate that we're about to find the fourth derivative. So you can say d raised to the fourth of the function. So if this was a function, we say 2x plus 1. Like we used to write d bar dx of 2x plus 1. That is, we're about to differentiate to find the first derivative of this expression, right? So this can also be fourth if we want to find the fourth derivative of this expression. Now, so all of these just the same. Okay, so let's go now. Let's go to these problems. So if you want to find the first derivative, you have a notation in this form. You want to find the fourth derivative, the fifth derivative, the sixth derivative, and so forth. You can use these functions. So whenever you see d raised parenthesis opens, 4 inside or 5 inside or 6 inside or whatever the case might be, they are trying to tell you that you must find that derivative. Now note this. Y raised to the power 4 is not equal to y raised to the power 4. Y raised to the power 4 that is in parentheses is not equal to y raised to the power 4. This is y to the fourth power. This is the fourth derivative. So take note of that. Okay. So we solve the first problem. First problem says y equals to x cubed or 3x cubed minus 3x squared plus 2x plus 1. So y prime. Differentiate. 3 times 3 is 9. Subtract 1 from this power is 2. 2 times 3 is 6. Subtract 1 from this power is 1. This is 1. 1 times 2 is 2. Subtract 1 is 0. So it's just 2. A times x, a times x raised to the first power is just equal to a in general. So even if this a is -3, it just equals to -3. If this a is 1/2 x, is just equals to -1/2. Whatever that is here, as long this variable is raised to the first power, it's just equal to that coefficient. So take note of that. So we've just found the first derivative. And this first derivative, that's exactly what we did in the previous lesson when we were finding the tangent and the tangent line of an equation. Let's say the equation of a tangent line and the normal lines. We told you that the first derivative is the slope. And also the first derivative is the velocity of a function. So the second derivative now is the acceleration of a function. So we find the second derivative, we increase the stroke, 1, 2. So this one now becomes 2 times 9 is 18x. You reduce the power by 1. And then 6x is just 6. The rate of a constant goes to 0. So y prime prime, we can simplify this, factoring out 6. 6 into 18 goes there 3 times. 6 into 6 goes there 1 time. So this is the first problem. Let's solve all the problems. So the second problem says y equals the square root of x squared plus 1. So I can just rewrite it in exponent form, 1/2. So I can use the extended power rule. That is, I bring this power down, y prime is equals to 1/2. I rewrite this expression, and I subtract 1 from this power. So 2 times 1 is 2, so it's 1 minus 2 all over 2. So this gives us minus 1/2 times the derivative of what is inside. So the derivative of x squared is 2x, right? So now I can find the second derivative. Now this 2 cancel this 2. This is now equal to x times x squared plus 1 raised to the power minus 1/2. I can find the second derivative using the product rule. If I don't want to use the product rule, I want to use the quotient rule. I can bring this expression with the negative power in the denominator and use the quotient rule. So I use the product rule. I hold the first factor, x, and differentiate the second factor. So I bring this 1 minus 1/2 down, rewrite what is inside using the extended power rule, subtract 1 from this power. So it will give me minus 3/2. Then differentiate what is inside, give me 2x. So I held the first function first and differentiated the second one. Now I must hold the function that I differentiated the first time and differentiate the one that I did not differentiate. So the derivative of x is just 1. So now I can just, okay, this second derivative, I can just simplify this 2, cancel this 2. X times x give us minus x squared. This power is negative. I can send it down in the denominator. It becomes x squared plus 1 raised to the power 3/2. Plus, now this is also negative. I can send it down in the denominator, x squared plus 1 raised to the power positive 1/2. And then this is 1 in the numerator. So now I can find the LCD. Y prime prime equals the LCD for the both of them. So now this is half. This is half. This is 3/2. So this is bigger than this. So the LCD is x squared plus 1 raised to the power 3/2. So now this goes into this one. It's just 1 times. So it's just like x squared times 1, right? Plus this goes into this. It's like you say this half goes into 3/2. What will be left? So it's like 3/2 divide 1/2. Reciprocate 3/2 times 2/1. So you're left with 3. So it means this is x squared plus 1 raised to the third power. That's it, raised to the third power. So we can finally just rewrite this as y prime prime equals, so we can write it one first. We say x squared plus 1 raised to the third power minus x all over x squared plus 1 raised to the power 3 over 2. This is our final answer. So if you want to rewrite it in other forms, it's up to you. You want to leave it like this, it's up to you, whatever the case might be. Okay, so we do the third problem. So the third problem says x squared plus y squared equals a squared. So this is an implicit equation. So whenever we differentiate the function y is the name of the function, we must attach y prime. So this gives us 2x plus 2y. Then we attach y prime. Derivative of this one now is just 0. This is a constant. So we solve for y prime. So it's 2y, y prime equals, send this one across, minus 2x. So we can divide both sides by 2y and by 2y. So we have y prime to be 2 and 2 cancel, negative x over y. So this is the first derivative. Now we find the second derivative using the quotient rule. So we say y prime prime equals, this is negative, we must factor it out. We hold this y and differentiate this x, it gives us 1. Minus, quotient rule says we must attach minus. We hold x and differentiate y gives us 1, but we attach y prime because y is the name of the function. Divided by what? So we divide this by y raised to the second power. Okay. Now, remember initially we had y prime. So because we had y prime, whenever we see y prime, we must replace y prime. So this y prime prime now gave us, now we multiply, this time this give us, so we read the positive first x y prime minus y all over y squared. So in fact, this y squared would just be y squared equals to x squared. Okay, let's put the positive first. A squared minus s squared. So a squared minus s squared will be our y squared. So let's first bring in this y prime. So y prime prime equals, this y prime is just x over y. So this is, there's a minus sign here. We already multiplied it, in fact. So this one now is x times this y prime now is minus x over y. Minus y, all divided by y squared. So y prime prime equals, so we multiply, you have x squared all over y minus y divided by y squared. So y prime prime, we find the LCD is just y. So we have y into y, one times minus x is minus x squared. 1 into y is y times y is y squared. And then times 1 over, because if we reciprocate this, it becomes 1 over y squared, right? So y times this y squared gave us, so let's factor out the negative. We now have x squared plus y squared all over y times this gave us y cubed. So we know that x squared plus y squared is equal to a. So x squared plus y squared equals a from the beginning. So we can replace x squared plus y squared to just be our a squared all over y cubed. But y cubed, yeah, we can just simplify. Y cubed is the same as saying y times y squared. So we already solved for this y squared. So y squared is just, so it's a squared minus x squared. So now the last one that we need to replace is this y. So if we take the square root of this, take the square root on both sides, take the square root on both sides. So this cancel. So y prime prime is equals to negative a squared all over. This is just y, right? The square root moves, and then this is, so this is now a squared minus s squared, square root of a squared minus s squared. So this is just our final answer. So we just try to simplify the problem, in a simplified form. That's exactly what we were doing. So let's do another problem. So question number 4, xy plus y squared equals to 1. So again, this is implicit differentiation. X and y are mixed up in the equation. Y is not the subject of the equation. So whenever we differentiate y, we must attach y prime. So let's go. We have, now, you will not always have y to attach y prime. As long the name of that function is a particular variable, attach a notation, a derivative notation to that variable. Assuming you have arrow of t, for example. Or let's say you have the function arrow, and it's in t squared plus 1. And then what if you were to have arrow t plus 2t squared equals to 1? So because the function name is arrow, when you differentiate arrow, you must attach arrow prime. So it's not only y that you attach y prime to, as long the name of the function or the dependent variable, because in this, the dependent variable is y and the independent variable is x. X is a variable within the function y. So that's why we attach y prime. So we hold x using the product rule. We hold x and differentiate y. We just attach y prime because the derivative of y is just 1. Plus we hold y now and differentiate x, we get 1. The derivative of y squared is just 2y. Then we attach y prime. All equals to derivative of 1 is 0. So we solve for y prime. Make it the subject, and then we solve. So we make this y prime the subject. We have this goes across, it becomes minus y. So we can factor out y. We'll be left with x plus 2y and then y prime. So we factor out y prime. All equals to minus y. Divide both sides by this expression. Y prime will just be minus y all over x plus 2y. That's the first derivative. Now we find the second derivative, y prime prime. Using the quotient rule, we hold the denominator, x plus 2y, and then we differentiate the numerator. The derivative of y, it just gave us y prime. Plus, not plus, not but minus. For product rule is plus, quotient rule is minus. We hold y and differentiate the denominator, which is x. So the derivative of the denominator now, derivative of x is 1, and the derivative of 2y is just 2y prime. Divided by x plus y, 2y square, will double the power in the denominator, right? Always, don't forget. So we can now simplify. So we multiply. So y prime prime equals, if we multiply this negative by this one and this, so let's first remember you have to bring in y prime. What was y prime? So y prime was, we forgot. So we held this one, we differentiated y, we got y prime. So we erased the problem. We did not see what was y prime. So y prime was x plus 2y in the denominator, right? And then here was negative, because we held the denominator and differentiated y, we got y prime. So it was just y in the numerator was just y. Okay, that was y prime. So whenever we see y prime, we must replace by that expression. So this time this time this. So this gives us the positive first. Negative times negative is positive, so it's y 1 plus 2y prime, and then minus y prime x plus 2y, all over x plus 2y all square. Oh, that's it. Let's continue. So now we have to bring in y prime. We have to replace y prime in so wherever we see y prime, we must put in y prime. So this is 1 plus 2. Y prime now is just that, which is negative. So it's now negative 2y all over x plus 2y. That is y prime. Let me use parentheses. Then we have minus y prime again is, so negative and negative is positive. So it's just positive y all over x plus 2y times x plus 2y, all divided by x plus 2y all square. So we can simplify the numerator. That is this time this. So it gives us, this is y, and then this time this is just x plus 2y minus 2y all over x plus 2y. This is y outside. Similarly, this and this. So we just multiply, we have plus. So I can just attach xy, and then this and this give us 2y squared all over x plus 2y. So also I can attach this. This is xy, and this time this give us 2y squared, and this is also 2y squared. Yes, to get rid of that long solving whole thing. So this will cancel this one. Now this whole thing is being divided by x plus 2y all square. So what do we do next? We simplify again. So LCD, denominators are the same, so we just take one of them. So it's x plus 2y. Then we add a numerator, so it's xy, and then plus xy plus 2y squared. So if we reciprocate this one, it gives us times 1 all over x plus 2y. So this is square. No, sorry, this is not square. This is the one that is square. Okay. So xy and xy, remember this is the original problem. So xy and xy, so y prime prime is equal to 2xy plus 2y squared all over. So you have x plus 2y all raised to the third power. So you can factor out this 2. So 2 comes outside, you have xy plus y squared all over x plus 2y raised to the third power. So from the original equation, we can be able to solve. From the original equation, we can solve for xy. In fact, we know that xy plus y squared, xy plus y squared is equal to 1. So y prime prime is just equal to, this is 1. So it's just 2 all over x plus 2y all cubed. So this is the fourth problem. Let's do the last one. So the last problem says x squared plus y squared plus 6x is equals to 8. We differentiate this implicit differentiation as well. So this 2x plus 2y, we attach y prime plus 6 all equals to 0. We solve for y prime. So you have 2y, y prime is equals, so we send them across, is 2x and then minus 6. Divide this out by 2y, divide this out by 2y, 2y. So 2y cancel 2y, y prime is equals, if we left, we can factor out 2. So we'll be left with 2 plus 2 goes into 6 3 times, all over 2y. So 2 and 2 cancel. So y prime would just be minus x plus 3 all over y. Then we find the second derivative, y prime prime. Negative is outside, we hold y and differentiate this one. Derivative of x is 1, derivative of this gives us 0. Minus, we hold x plus 3 and differentiate y, we just have y prime. All over, we square y. Then we can bring in y prime. So we have y prime prime is equals, this is y minus x plus 3. Y prime now is just, okay, so this negative, this is negative, and then this give us positive. So y prime is just this expression, right? So this is our y prime. So we need to bring in y prime, which is now negative x plus 3 all over y. And then we can say this whole thing is divided by y squared. So we can simplify. So y prime prime equals, this is minus y plus, so this times this expression, because this is just multiplication, this time this x times x give us x squared, and then this time this as well. So all will be negative. But this time this gives us negative 3x. So negative 3x and this negative 3x give us negative 6x. And then 3 times 3 is negative 9. So all negative. Then we can divide it by 6, by y, that is y. So we find LCD. This divided by y squared. So y prime prime equals LCD is just y. So we multiply, this is minus y squared minus x squared minus 6x minus 9. We reciprocate 1 over y squared. So what do we do? So we can say, we factor out, let's factor out this negative. Factor out this negative. So we factor out the negative, we have y prime prime equals, so negative is outside. So we have positive y squared and plus x squared and also plus 6x. So we already see that we have y squared, x squared plus 6x is right here, and then plus 9. So I'm just going to group these ones so that we'll be able to factor that expression. Divided by y, and y squared give us y cubed. So this whole thing here is just equal to, what is here is just, this entire expression here is just equal to 8. So this is just equals to 8. So you have y prime prime equals negative 8 plus 9 all over y cubed. So this whole thing is just 8. Remember, we already factored out this negative. So now 8 plus 9 gives us 17. So it's negative 17 all over y cubed. But this y cubed, we can solve for this y cubed. This y, if we solve for y squared, is just equal to 8 minus x squared minus 6x. That is our y squared. So put in y squared, right? Then y, just y now, y would just be equal to the square root of 8 minus x squared minus 6x. So y cubed can be y times y cubed. That's a y squared. So we just simplify the problem further. So this is now negative 17 all over, this y is the square root of this expression, and then this y squared is this one. So we just have 8 minus x squared minus 6x times the root of 8 minus x squared minus 6x. But this root means 1 over 2. The bases are the same. This one is 1, and then this one is 1 over 2. So you can add the powers. So we add the powers, 2 times 1 is 2, plus this is 3. So this gives us, this can be rewritten as y prime prime equals negative 17 all over the root of 8 minus x squared minus 6x raised to the power 3. Yes. So this can be rewritten in the form of 8 minus x squared minus 6x. The square root of 8 minus x squared minus 6x, all cubed. So this is it. Thanks ever so much for watching. Please don't forget to subscribe to our YouTube channel. Like our videos, you can share with your colleagues or your friends or whatever the case might be. Just hit the notification button also so that you get a like to our new videos. And if you want to sponsor this program, if you want to be of help, you can be of help. Hit me in my inbox at yahoo.com. So you can send me an email and I'll get back to you immediately. Or you just leave a comment in the comment section. Thanks all so much. See you next class.